This is Mr. Ward, and this is Algebra Do Now 25.1. That's week 25 of the trimester, day one of this week, week 25 of the school year. The first week of the trimester was week 13. So really, this is going to be week 13 of the second trimester. So we've been going 13 weeks. This will be our 13th week we've been going. So the trimester ends on Friday. So let me know what you need in order to get things done so you're all set, because both linear and systems will be the focus of the report cards. All right, so this is a key. So the first thing we're going to consider is the other day you put on your fusion-powered propeller beanie and flew from just outside Newark, New Jersey, not New York, but Newark, New Jersey, which is close to New York, all the way to Honolulu, 4,896 miles away. It took you just 9 hours because there was a strong wind combining with your propeller beanie's normal speed and pushing you along. On the way back, it took you 16 hours to get home. So even though your propeller was carrying you along normally, the same wind was pushing back at you. So on the way, basically, you have your speed and you have the wind as a tailwind boosting you along. On the way back, the wind is in your face, which means it is a headwind. It's fighting you all the way along. Same distance either way. So what are the two key unknowns in this story? So you know how long it took you to get there. You know how long it took you to get back. You know how far it is either way. It's 4,896 miles either way. And you could even put this number and this distance and this time together and do distance divided by time to get your overall speed going there, and divide 4,896 by 16 hours to get your overall speed coming back. What we don't know is how fast your propeller beanie was carrying you along and would in still air. And you also don't know how fast the wind was. So if you thought this, how fast your propeller goes in still weather, and how fast the wind was blowing, those are indeed the two unknowns. And here we have some atomic beanie hats. We, of course, upgraded to fusion power instead of simple fission atomic power. So they're much more powerful ones now. They definitely will make you fly. Okay. Now, if you came up with all of that, that's great. Propeller beanie speed and wind speed being the unknowns, then that's great. Let's see if we can come up with an equation. So what we have going to Honolulu is we have your speed plus the wind speed helping each other along. And that's all equaling the overall speed, okay? And I'm going to come back to that in a second. On the way back, you have your speed minus the wind speed, because it's now a headwind fighting you all the way, and that equals your overall speed. Okay, but what is your overall speed? Well, here's the hint. If you divide overall distance by overall time, you get the overall speed. So let's do that. So overall speed going there is going to be your distance divided by time. And time going there was 9 hours, and distance going there was 4,896 miles. So that actually, if we simplify that, we will have your speed going there. Now the speed coming back is going to be the same distance, 4,896. Now it's going to be divided by 16 hours. So that'll be miles per hour. So we can work out from that what your overall speed was. So your speed plus the wind speed, which is your tailwind at that point, would be this fraction, which we could simplify. And your speed minus the headwind fighting you on your way back would be this overall speed. Let's actually work out what that is real quick, because we can do that. So we'll go over here and let the internet do it for us. 4,896 divided by 9 is 544. So there we go. That's going to equal 544. And if we did the same dang thing with this number, 4,896 divided by 16, we end up getting 306 miles per hour as your overall speed. So that's going to be 306 miles per hour. Okay, so there you have all of that. I'm going to go ahead and call that miles and that hours. It's always good to label the parts of what you're doing because it helps you keep track of what all these numbers are. So you're not just shuffling numbers around. They actually have some meaning. Okay, there you have a couple of good equations for this. And there we have an actual footage of an actual propeller beanie working quite well. That's a more prototype model because it's a little larger than it needs to be for it to work. So let's go to Desmos. If you came up with those two equations, and of course that one could end up being 544, and this fraction could be 306, that's fine. Let's go into Desmos and see what happens when we graph them. So we're going to have the first equation, which was x plus y equals 544. The other one was x minus y equals 306. And we can zoom out to get to where we can see our two graphs. Now there they are. Okay, so there's a point where they intersect. That's a point that makes both equations true at the same time. So 425, 119. So I'm going to put that point 425, 119. I will label that point, and we will label that point. Let's see, what does that mean? 425 miles per hour for the beanie and 119 miles per hour for the wind. And that is what that point means. Go back, put that in here, and this is what we got. This is the solution that makes both equations in the system true. And that is the key thing that makes something a solution. All right, so let's consider these same two equations. So we've just graphed them. Now, we simplified them all, just like I just did, into x plus y equals 544 and x minus y equals 306. What happens if we just add those two equations vertically? Well, x plus x is 2x, and y plus negative y is 0y, which we will not care about because we're adding it. And then we will add 544 to 306, and 4 plus 6, that's 10. Carry the 1. 4 plus 0 plus 1 is 5. Nothing to carry. 5 plus 3 is 8. And now we can simplify that into 2x equals 850 and divide both sides by 2. And we get x equals 425 miles per hour for fusion-powered propeller beanie in still wind. No wind at all. Okay? If there's no wind at all, that's what you do. Now, on the other hand, notice we eliminated the y variable. We eliminated the wind speed by adding them. Now we're going to subtract them. Okay, when we subtract them, we're going to subtract your speed and make it go. We're going to eliminate the speed of the propeller beanie and leave the wind speed. So x minus x is 0x. Y minus negative y is going to be 2y, because and subtracting a negative is like adding a positive. So 1y minus negative 1y is the same as 1y plus 1y, or 2y. And then we're going to subtract 306 from 544. So I subtract 6 from 4. I got to turn that into a 14. I'm borrowing from the 40, picking a 10 over here. So 14 minus 6 is going to be 8. This is a 30 instead of a 40, so it's a 3. So 3 minus 0 is 3. Then 5 minus 3 is 2. And I'll simplify that. 2y equals 238. And I'll divide both sides by 2. And then y is going to equal 119 miles per hour for the wind. Helped you, then fought you. And that is that.